Hello, my name is Jonathan McLean. I'm doing my presentation on SQL injections. I'm currently a senior data analyst at Merkle and also a current grad student here at UCA. I chose this topic because I work a lot with SQL queries, and this is just something that I thought was very interesting. So let's get into it. Let's start with the definition. So what is a SQL injection? A SQL injection is the direct insertion of malicious SQL statements into a user input field or by other methods that are then executed by the server's database, causing unwanted behavior and database operations. So what is unwanted behavior? So unwanted behavior could be a number of things. That could be, inserts or updates to the SQL database that are, not intended to or were caused maliciously. It could also be data leaking, so such as an individual searching a select star across the entire table, or or even exporting out of the database using a database command. Why are we looking into this? Well, SQL injections are one of the three top web vulnerabilities in 2022, and still are one of the major vulnerabilities in 2024. They cause $1 million of damage every year, and they continue to do so. SQL injections can be very difficult to detect, and some vulnerabilities still exist today, but haven't been exploited because attackers either lack the knowledge of the database structure or just lack the schema knowledge. So some of these just exist around right now. It's just that attackers just don't know you know the exact queries or what to do to get the database or whatever malicious attack they were trying to get across to do so. SQL databases exist all across the internet, from Netflix, Amazon to Uber to Pinterest. They exist all over, and in the foreseeable future, they will continue to do so. Now we know what a SQL injection is. Let's look at where SQL injection occurs. Here I placed three different queries that I'm going to break down here in a second, but I wanted to go over the general rules or ground rules of SQL query. SQL query is made up into three segments. It's usually defined as a select, insert, update, or delete, and then it usually references a table, and then whatever your query actually is. So SQL injections can occur at all points in a SQL query. 90% of them do occur in the where statement here, but they do occur all over. Insert statements, for instance, can have values changed or modified. Select statements can be altered to include more columns or alter the order by to show more recent columns or out of order. Updates can be altered so they do not run, or they include additional fields that are not meant to be updated. Here in the first example is the update statement. So you have to use your imagination here. So let's say that you are going into your bank account and you're trying to withdraw $200 at an ATM. So let's say that it's a very basic system, and here we are, where we put our username and password, and we are withdrawing $200. So what a SQL injection can do, or a user who has knowledge of the database can do, is whenever the user is inputting their username, they can include the text here in red. And so what this will effectively do is it will say, hey, username is equal to John, and then it will continue and look and examine the next part of the query logic, and it'll say, and 1 is not equal to 1. Well, 1 is equal to 1, so what this effectively does is just nullifies the statement. So what will happen is the user will get their $200 withdrawn, but whenever the update statement goes to run on the database, this query effectively does nothing. So the user keeps their $200 in their account, and then also gets the $200 into their wallet. The next one here is an insert statement. So what I want to do here is kind of show you how a user can kind of change an insert statement. So what we're doing here is the user's going in and is creating a new bank account at Arvest, for instance, let's say. So one of the things they can't actually fabricate is an account number. So what they do is, they enter their personal information. So they say, hey, my name is John Jobert, but within the last name field, they include the text here in red. And so what they're saying is that, hey, my name is John Jobert, and then the amount I'm investing is $10 million and get date. But in reality, whenever they went into the bank, they only had $200. So what this is doing with the comment is just nullifying everything else. So in the insert statement, we're inserting the account number, which is made by the insert. We're giving them the first name, last name, the account amount, and then a create date. Now, I'll reference this later on. The user would have to specifically know how the insert statement works and what fields to include. And so a lot of times users, whenever they find these vulnerabilities, will ping several different attempts. So their first attempt might just include, first name, last name, and amount, and then they found that the query failed. And then they'll retry again and again and again until they get something to work. And so it's just kind of trial and error until we get these injections to work. The next one we're going to look at is kind of a union affecting the where statement. So let's say that you're putting in your username and password and you're trying to, look at your personal information on your account. If you include in the password field the text here in red, what that would effectively do is it would give you not only the first instance here, so this query would run, and it would give you just your current, user information. Once the union though goes to effect, it will then dump all the remaining other users out into the text dialog for you to look at. So this is kind of really useful for an attacker to do if they're trying to just looking at what's in the database, looking for passwords or looking for financial information, just trying to get something to further their attacks or progress their attacks to a larger scale. Next, let's look at how SQL query attacks work. First step is identification. Attackers must identify SQL injection sites on a web application. One does this by testing input fields with character like or what's highlighted in yellow. These characters are known characters in SQL. For instance, the single quote, signifies the end of a text field or the beginning of a text field for a string. There's a comment for the slash star, the and to or operators, as well as the semicolon to state the end of an SQL query. They will use an automatic programming technique to test bench all the available options for input. Sometimes they include accent characters and null characters or invisible characters. So what they're effectively trying to do is, try to either get a successful query to go across or try to, get the database to produce an error code. A lot of times giving accent characters or null characters, or, even invisible characters will cause, the strings or, sort things are in the database to malfunction and cause strange errors to occur that the attacker can use to then manipulate the database. The next part is construction. After you've identified the vulnerability, the attacker will then construct a malicious SQL statement to insert into the input field. The attacker will poke and prod the database with several queries to configure the database structure and to figure out the database structure and schema. This kind of coincides with part 3, so execution. So the code is passed to the database for execution, where the attacker is updating and selecting or deleting from the database data from the database. Effectively, what you're most of the time doing is you're sending 2 lines of code instead of 1. So SQL is a top-down language, so the first will run and the second one will run in sequential order, and it's not looking, I'm saying, hey, I'm defining just the one run, with just saying 2, and so it's running both. 1, 2, and 3 are kind of run and tangent. So the attacker will try one query and construct another one, execute, construct another one, and execute. And so they're kind of just, like I said earlier, poking and prodding around the database, trying to get extract various informations or, push the database to the limit to see what the attacker can do. So one of the things they can do is gain access to the username and passwords, and that's what step 4 is. So after you've gathered all of your information, the attacker can now log in as the admin, where they can enable database features and instruct information and kind of do freely whatever a developer would be able to do normally. So at this point, you have full access to the database and can do whatever you want to do. Continuing on, I want to do a brief kind of history on SQL injections. I've only chose 2 examples that I thought were interesting. There's countless more, but I just thought that these were interesting. So first one was the UK Talk in 2015. One of these was there was an outdated database library out on the database, which allowed hackers to inject SQL queries onto the web through the backend. So what essentially happened was hackers found out that the TalkTalk company was, running an older database version, and so what they did was looked up, the newest version and went through the notes and found out known exploits for that current version, and so or previous version that they fixed in the current version, and then they went back to that old version and then used those exploits to gain access in the database. So this was just kind of a lazy practice by the company, which you should regularly do. At my company, we do security checks where these libraries are checked constantly and just kind of making sure everything's up to date and the ship is tight. Sony Pictures in 2011 was another attack where Sony's PlayStation Network suffered a SQL injection attack where hackers copied all the major SQL infrastructure and then deleted it. Once it was deleted, attackers then blackmailed Sony for them to have access back, and then they used all the personal information and leaked it online. I'm going to quickly go over the two different main types of SQL injections. The first one is an in-brand SQL attack. In-brand SQL's attack is when an attacker is using the same communication channel on a web application to attack or gather results. So mainly what this is they're using input fields on the web application to insert their SQL injection and do malicious things. There are two subtypes to this. One is the error-based SQL injection, where the attacker is injecting bad SQL code to obtain or gain database structures or schemas through error codes. So a lot of times, if you don't have your error codes, filtered out, they'll pass that on to the user and specifically tell you, hey, this is the fields are specifically in a table that you don't have. Then the attacker can then know, hey, these are the fields in this table. The second is a union-based SQL tag. The attacker leverages union tagging on a union at the end of the SQL query to then kind of do whatever they need to do in the database. One of these is an example is let's say that you are entering your first name and last name and email into a website. What you're effectively doing is like, hey, putting my email and selecting where my email is equal to this, and then I tag on a union within my email field, which is the text highlighted in yellow. And what this effectively does is it dumps out all the emails in their current email system to your screen. And so it's just another type of SQL injection. The second type is inferential injections. This is pretty high end. You won't see this very often, but this is where the attacker attempts to reconstruct database structures by sending different payloads and observing responses and behaviors from web applications. The attackers will not be able to directly see the results, but they're looking for server responses to validate if attack worked. You don't really see this too often, but I want to get to the important part, which is the prevention. So let's move on to the next slide. Prevention. So after we've learned about SQL injections, how do we stop these? One of the main ways to do this is using a prepared statement. So a prepared statement is an SQL statement template that uses input fields as parameters. So whenever you hit this submit button on a web application, what it would do is the server breaks up that input kind of as a text field and kind of chunks it out. Once that's chunked out or parsed out, it puts them into the parameter field of the SQL statement and then runs it. And if any extra text was provided by the user, it just kind of uses it as dummy data. So a lot of times this kind of fixes union attacks or them trying to tag on additional things in the SQL statements. It just does a really good job of doing that. The second way is stored procedures. So stored procedures allow developers to use catch and try exception error blocks that can limit the exposure of errors and issues in the database. So it kind of just says, hey, attempt to do these things, and if they don't work or if there's a failure occur, stop and then produce a structured error that you can send out to the users. They're very clean. You can validate your input and add layers of production, and it's a very nice and clean way to do so. Continuing on with this, the third next way to do this is following the practice of principle of least privilege. So any database action should be based on a case-by-case scenario or role-based. So read and write access should not be guaranteed across the whole database to every single user. So a lot of times, you should only have read access if you're, for instance, a solution manager, and execute privileges and read access if you're a developer. So, and then within those, you should only have, as a developer, have access to certain clients or certain segments of the data that you, as a, where your responsibilities lie. The next part or way to limit or prevent SQL injections is monitoring application and database inputs. So all databases should have a DBA or security team that monitors unusual database actions. There are different tools such as in AWS, such as CloudWatch. SSMS has database tools as well, and just as a nice way to monitor database and make sure that nothing goes awry. So, for instance, if you're having an email system and you know that the queries should only run for a fraction of a second, but you see them running for a whole minute, you should know that, hey, something's happening in this query field, and we need to investigate and kind of figure out what's going on. The fifth and best way to practice or implement prevention is filter your database inputs. So clean all your data and coming in, filter everything: bad characters, invisible characters, null characters, validate all your fields. So for instance, if you have an age field, validate it against known integers. So you should only have age 0 to 120, or 150 if you want to be safe. And if any extraneous digits or a text value were given, it instantly rejects that record. It tells the user to try again. This is probably the best prevention method. Just clean everything up and cross your T's and dot your I's. So that was my presentation on SQL injections. Thank you for your time, and if you have any questions, please email me. And thank you for everything. Bye.